Welcome to Math Fact Fluency, where we will discuss addition and subtraction. Before we begin, let's take a look at a video of a math class.
I think it's already starting. Okay, here's your homework. First let me tell you the directions. What's 4 take away 5?
1, 2, 3, 4, 5, 6.
Take away. What's 6 take away 1?
1.
No, you take away 1 out of 6. How much does it equal? What's 10 minus 1?
I don't know.
1, 2, 3, 4, 5, 6. 6, 7, 8, 9,
10.
Nope. Take away 1. How much is this?
1, 2, 3, 4, 5, 6, 7.
Nope. 1, 2, 3, 4, 5, 6, 7, 8. And one more. And add one more. How many does it equal?
1, 2, 3, 4, 5, 6, 7, 8. 1.
It makes 9. See how you take away? You take away 1 and it equals
1.
Do you get it now?
Yes.
Have you ever felt this way in math class or had students looking at you like the young man in the video? I know I have. I realized early on in my teaching career that just because I told my students how to do something, if I didn't ground that instruction with clear, precise direction and strategies, I would definitely feel like this teacher at the end of the day. Today, we are going to help you discover ways you can support your students with math fact fluency. However, we are going to consider 3 questions. What does fluency even mean? What approaches to building fluency with facts help our students become confident and competent mathematical thinkers? And also, what does meaningful practice look like? We know that we want our students to be able to quickly recall or have what is known as automaticity of their math facts, whether it's their basic addition and subtraction facts or their basic multiplication and division facts. First, though, we have to understand what fluency is and what it is not. Fluency means noticing relationships and using strategies. We want our students to be able to recall with ease and automaticity of their math facts, but there truly is an art in helping our students to become fluent with their math facts. Fluency is the skill in carrying out procedures with flexibility, with accuracy, and with efficiency. Thus, far from just being a measure of speed, fluency with facts involves flexibility and accuracy by using an appropriate strategy to find the answer efficiently. Defined, accuracy is the ability to produce mathematically precise answers. Efficiency is the ability to produce answers relatively quickly and easily. And flexibility is the ability to think about a problem in more than one way and to adapt or adjust thinking if necessary. It is also important that students are able to select and apply a strategy that is appropriate for solving the given problem efficiently. also known as appropriate strategy use. However, this strategy may be different for different people, and we as teachers must be willing to be open to students choosing strategies that work for them. According to the National Council of Teachers of Mathematics, fluency is also the ability to transfer procedures to different problems and contexts, to build or modify procedures from other procedures, and to recognize when one strategy or procedure is more appropriate to apply than another. To develop fluency, students need experience in integrating concepts and strategies and building on familiar strategies as they create their own informal strategies and procedures. Students need opportunities to justify both informal strategies and commonly used procedures mathematically. They need to support and justify their choices of appropriate procedures and to strengthen their understanding and skill through strategic practice. Procedural fluency builds on a foundation of conceptual understanding, strategic reasoning, and problem solving. Second, another important note to share is that fluency is knowing from memory and not the term memorization. With repeated experiences working with a number, students can come to just know that 2 and 2 is 4 without ever having had to memorize it. At this point, we say students have mastered their addition facts as they become so fluent at applying their strategies that they do so automatically without hesitation. So, how is fluency developed? Students develop fluency as they progress through 3 developmental phases. In the first phase, which is known as foundational facts, they are modeling and or counting to find an answer. In phase 2, we have what we call derived-fact strategies. This is where they're taking those foundational facts and deriving answers using reasoning strategies that are based on those facts. And then finally, phase 3 is when we call our students fluent. They have mastered their facts and because they're able to efficiently produce answers to the basic math facts. Traditional approaches to learning math facts, which included our flashcards, our drill, and our time testing, attempted to move students from phase 1 directly to phase 3 without even going through phase 2. This approach is ineffective. Many students do not retain what they memorized in the long term, moving to the next grade level still not knowing their facts. Even if students remember facts, they are unlikely to be fluent as we have defined, as they will not have learned how to flexibly apply strategies to find the answer to a math fact. Research tells us that students must deliberately progress through these phases with explicit development of reasoning strategies, which help students master the facts and gives them a way to regenerate a fact if they have forgotten it. Students make more rapid gains in fact mastery when emphasis is placed on strategic thinking. So, how do we help children progress through the 3 phases with respect to math facts? What a great question. Careful sequencing and explicit attention to strategy development is necessary. So let's take a moment to look how we can begin to assist our students with math fact fluency by honing in on phase 1 through explicit teaching of the foundational facts. The first group of facts to master involves adding or subtracting 0, 1, or 2. This is because these facts relate closely to the counting sequence. Visual tools such as number lines are especially helpful for connecting these facts to the counting sequence. Exposing students to real-world contexts naturally involve adding or subtracting 1 or 2. However, the use of stories is especially important for helping students make sense of the meaning of adding or subtracting 0. It is important to go beyond simply teaching a rule like adding or subtracting 0 keeps the number the same. Instead, we need to encourage students to use the meaning of the operation to understand why this is true. Oddly enough, the research shows that students can more easily master their doubles combinations, such as 2 and 2 is 4 and 3 and 3 is 6, than most other groups of facts. The ease of this mastery, combined with the observation that more difficult facts later on, such as 7 plus 8, are close to doubles facts, make the doubles a particularly useful group of foundation facts to learn. Another addition foundational facts is the combinations of 10. These are also related to the counting sequence. Students are able to count on to find the missing addends that are equal to 10. For example, 4 and what number is 10? I can start with 4 and I can count on to 10, finding 6 numbers. So 4 and 6 is the same as 10. Understanding that a teen number comprises of a 10 and some more units is a key goal in our early grades and is essential for eventually using some other derived strategies known as making 10 and pretend to 10 that we'll talk about in a few minutes. Use of the double 10 frame is helpful to students as they begin to understand their teen numbers. Of course, placing context with the exploration of our 10 plus facts is advantageous for our students. So once students have automaticity with the foundational facts, students are ready to find an addition or subtraction fact within 20 using a derived fact strategy. We are going to explore 3 derived strategies known as near doubles, making 10, and pretend to 10. However, your students may invent their own strategies, which is completely fine. Let's begin with the near doubles strategy. Students can be encouraged to work from a known doubles fact to derive a more challenging related fact. For example, they may solve 6 plus 7 by starting from a doubles fact of 6 plus 6 is 12 and adding 1 more to get 13. The making 10 strategy relies on 2 groups of foundational facts: the combinations of 10 and the 10 plus some other number facts. In addition, students must also be able to decompose numbers within 10 because if they are given a sum where one addend is close to 10, such as 7, 8, or 9, they might need to decompose the other addend to complete a combination of 10. Now, let's focus on a few subtraction-derived facts strategies. The first is called counting up or counting back. Although counting methods are generally not most efficient, there are exceptions. Let's consider the math fact 11 minus 2. We can actually solve this efficiently by simply counting back from the minuend, or in this case, the 11. Conceptually, this connects to subtraction as takeaway. So if I start at 11 and I subtract 2, I can get 9, so I can count back. In a problem like 8 minus 6, you may find it efficient to count up from the subtrahend, or in this problem, the 6. So if I start at 6 and I count up 7, 8, I realize that that answer is 2. Conceptually, this connects to subtraction as compare, finding the distance or difference between the two numbers. One key to developing fluency with subtraction facts is helping students to recognize the distinction between takeaway and compare situations. Students who always think of subtraction as taking away, especially with facts where the two values are close together, like 8 minus 6, are not using an efficient strategy. A number line can help students contrast these two situations. Addition is generally easier than subtraction to many students. Therefore, it is no surprise that many students approach the learning of subtraction facts by thinking of related addition facts. For example, when finding 12 take away 5 or 12 minus 5, students may instead think 5 plus what number is 12 and rely on their knowledge of addition facts to solve. Notice this strategy is connected to and advances the counting up strategy. Think addition can also be supported by the number line. Students may also make use of their knowledge of combinations of 10 and the 10 plus facts to help them find subtraction facts. This often occurs when the minuend is a teen number and the subtrahend is slightly less than 10, such as this example, 15 minus 9. The 15, which is our minuend, is a teen number, and the 9 is very close to the 10. We can use a number line and the benchmark of 10 to help identify the difference. The first two strategies in this group, the down over 10 and the up over 10, are virtually counting back and counting up strategies. Instead of counting by ones, however, students start at the number, jump to the 10, and then jump to the other number to find the difference. In this example, which we will call down over 10, students can use this reasoning strategy to go down to 10 in one of two ways. The first, in this representation, students begin at the minuend, or the 15, and jump back to the benchmark of 10. Students will determine this jump was 5 of the 9 in this example. So 5 of this subtrahend, the 9, and then they jump backwards again 4 more places. So 5 and 4 more equals the 9. Then they figure out that the difference is 6. This is takeaway thinking. Another down over 10 strategy is known as find the distance or find the difference thinking. In this representation, we will see that students are able to use the benchmark of 10 again to help find their distance thinking. Students are able to think that the distance between 15 and 10 is 5 plus one more jump to get to the 9. So the difference from 15 and 9 is a total of 6 because it took us 5 to get here and one more. Finally, students can use the counting up strategy and the benchmark of 10 to determine the distance up over 10 thinking. You can see here that students will use the benchmark of 10 to launch their thinking, and from 10, they jump to the minuend, or in this problem, 15, to find the distance of 6 between 9 and 15. So we jump to 10, and then we jump to 15 to get to our minuend. There is no doubt that practicing addition and subtraction facts are essential for mastering them or achieving phase 3 of becoming fluent with their math facts. To maximize precious class time spent practicing facts, embedding that practice in worthwhile mathematical activities is important, and the expectation in GCPS. Our office does not condone the drilling of students through flashcards or by assessing them through timed tests. Drilling isolated facts may, over time, lead to memorization of those facts, but that is the only gain. In contrast, meaningful practice involves helping students learn their facts through rich, engaging mathematical activities that provide the additional benefits of promoting problem solving, reasoning, and communicating mathematical thinking. Meaningful practice of multiplication and division facts begins with the use of related problems. It can be sustained throughout the year by reminding students to think of strategies they know when solving an unknown fact, and by expecting students to articulate those strategies verbally and in writing. Please be sure to check the ECOMM for great examples of meaningful practice for your students. Joe Bowler, a British education author and professor of mathematics education at Stanford, leaves the following quote for us to consider. Research evidence points in one direction. The best way to develop fluency with numbers is to develop number sense and to work with numbers in different ways, not to blindly memorize without number sense. To avoid pitfalls, we would like to offer a few tips to help you assist your students in becoming fluent with their math facts. First, it goes without saying that students will be more successful as they are efficient with those foundational facts. Often students are unable to make sense of the derived-fact strategies presented in quick succession after the related foundational facts. This is why it's important to throw away those time tests and those flashcards. Under the pressure of time, students just default to counting or detach from thinking rather than slowing down to consider a strategy that would eventually help them become faster and more efficient. Next, it is important to explicitly teach the strategies presented throughout this presentation, as well as using the resources found on the ECOMM to help students to acquire the strategies to help them acquire their math facts. Use of manipulatives and visuals are always encouraged in all math experiences to ensure student success. Allow students to become familiar with strategies. Making sense of how the numbers are working together is how students become fluent. And remember, efficient to you and me might be different for our learners. It is important that students have strategies to draw from. We want students to have the ability to select and apply a strategy that is appropriate for solving the given problem efficiently for them. So this all sounds great, right? You're on board. But now what? That's a great question. Let's go to the ECOMM and see what resources we have to help you with teaching our students how to become fluent with their math facts. Usually when you go to the ECOMM, you go straight to your grade level and you go find all the wonderful resources that are available for you. But instead, I encourage you to take a look every so often at our math office page. We also have a lot of great information there for you that will help you with your students. So once you've clicked that math button and you scroll down, you'll be able to find all sorts of learning opportunities, our math newsletter, traditional versus task-based instruction, all of those great things. But today I want you to go all the way down to where it says instructional resources, and there's a yellow button that says all about math fact fluency. When you go to this site, you will find some general information about what fluency involves, all the things that we talked about today in the video. When you scroll all the way down, you will find two links. One is addition and subtraction fact fluency, and the other is multiplication and division fact fluency. But you can go straight up here to the different tabs and select as well. Either way, your choice. So if I were to go to this link, addition and subtraction for fact fluency, we have provided you with some resources to help you, our students, parents, and our students become fluent with their math facts. These resources that I'm going to show you are from Jennifer Bay Williams and Gina Kling's book, Math Fact Fluency. They provide games and assessment tools to support learning and retention of math facts. While the games I'm going to show you that the authors provide give us the opportunity to talk about strategies and practice a newly learned strategy, we encourage that these games do not take the place of problem-solving tasks in the classroom, where students are able to participate in those mathematical tasks that require collaboration and critical thinking. We offer these games as a way to introduce the game in a teacher-led small group based on data that indicates students that need explicit instruction on strategies of those basic math facts. Once you've taught them the game, we encourage you to bridge the parent partnerships within your classroom by having the parents play the games with their children at home, which is a fun way to lead students to math fact fluency. So let's take a look at the site a little bit more. Once you scroll down, you will find all of the foundational facts and the derived fact strategies that I've talked about today in this video. Just a kind of a reminder. Over to the right, you'll find two different drop-down menus. These are the activities for the foundational facts, and then the one at the bottom is for the derived strategies facts. So if I were to click that arrow, you will find different types of games that kids can take home to play. So if I was working on my combinations of 10, there's a game called 10 Sleeping Bears. And when you open this up, you will find that there is a front page that tells you how to play the game, the different materials that are needed. This one needs a 10 frame, some plastic bears, or they can use counters or pennies, whatever, and a cup or a bowl for the cave. This is something that is very similar to some of our tasks that you can find on the ECOMM. But it tells the parents how to be able to play. There's even variations. And if necessary, we also provide you with either a recording sheet or the game board that is played with that game. Just so you know that all of the games that we have listed here have materials that might be needed, such as playing cards or dice. In this case, it's a 10 frame you might need to share with the parents, or print this out to give to the parents, and then they can find some counters. But everything that the students will need are items that are found in the home. Another neat thing that's on here is the observation tools that you can use when you are working on the different strategies. For example, this one here, when I click this one, it will show I can write my students' names on the left, and then I can figure out when they are able to figure out that 2 and 8 is 10, if they're automatic or if they're just accurate, because they might have a different strategy that they're using. But some different things you can use in your classroom to help with that math fact fluency. Also found on the site are different math office resources, like the counting routines from kindergarten, the analyzing the standards from first and second grade that support math fact fluency. These are ways that you can help support your students in the classroom with different games that can help students have fun in learning their math facts and not be worried about those time tests. So as we come to a close in this video, I would like to offer these two summary questions for you to consider. How will you support and develop fluency in your classroom? And a final question, what ideas or activities are you most excited to try with your students? As I leave you today, please reach out if you have any questions or would like a thought partner about how I can support you and your students in their quest to master their math facts. Here you can either email me or call me on my office phone, and I am here to support you. And good luck with your students and their basic math fact fluency.